Hello, in this video we're going to take a look at this word problem here. So, Edmonton CN Tower is a high-rise office building. From a point 35 meters from the base of the building and level with the base, the angle of elevation of the top is 72.5 degrees. We want to find the height of Edmonton CN Tower to the nearest meter. So the first thing we want to do with this problem is we want to be sure that we draw a picture. It's so important to draw a diagram because it allows us to explain ourselves and allows us to see things that we otherwise might not notice. So it doesn't have to be a fancy diagram. So we're going to imagine that this line is the CN Tower. And we said that from a point 35 meters from the base of the building. So out here, so there's 35 meters. And it says level with the base. So that means that the angle here is 90 degrees. And so here we see the angle of elevation to the top is 72.5 degrees. Let's take a second to make sure we understand what angle of elevation and angle of depression mean. If you imagine looking from your eye there, imagine putting a horizontal line straight out. Angle of elevation is the angle that is, that little shift there. Angle of elevation is the angle measured from the horizontal up. Angle of depression is the measurement from the horizontal down. So this is angle of elevation. And this is angle of depression. So in this problem, it's stated that from a point 35 meters from the base of the building and level with the base, the angle of elevation of the top is 72.5 degrees. So that means that your angle of elevation is measured from here, and that's 72.5 degrees. When we're interested in the heights, we're going to put an H here. So now that we have our diagram, we can label this if we want with letters. So let's just call this a triangle ABC. So we need to find H. Now a quick question to ask yourself before you do this problem. What will the size of H be based on what we see? Well, if we take a look at this right angle triangle, we have angle A is 72.5 degrees, and we have angle C is going to be some angle. We could calculate that, but it is going to be less, significantly less than 72.5 degrees. So remembering this idea of largest angle, largest side, smallest angle, smallest side, middle angle, middle side, I know that H is going to be significantly larger than 35 meters. The reason why it's good to ask yourself this question and identify that is the most common mistake is students will make a mistake when they set up their ratio. And though the question will work out, you'll end up getting a value of H that contradicts this property. So this is a right angle triangle. To figure out what ratio to use, so I'm going to write down my SOHCAHTOA. I know I'm given an angle of 72.5 degrees. H is the opposite, and 35 meters is the adjacent. So I see that I'm going to use the tan ratio. So tan of 72.5 degrees is equal to the opposite H over 35. And now we do a little bit of algebra here. So we multiply both sides by 35, and we get H is equal to 35 tan of 72.5 degrees. Now, I'm just going to take this and sub it into my calculator. Now, a little thing I've been reminding students is that when you get a calculator, you should be pretty comfortable with your calculator. And one thing that's always good is always when you get your calculator, take the sine of 30. And we know that the sine of 30 is 1/2. It's one of those values I've mentioned that's good to memorize. And we get 0.5. Another one you could take to check is you could take the tan of 45. and we get 1. The reason why is, if we come up to settings here, you'll see that there's an option to change your angle unit to this unit called radians, which radians is just a different unit for angles, but notice that tan of 45 is no longer 1. Sine of 30, oops, let's clear this. Sine of 30 is no longer 0.5. So it's good to have memorized tan of 45, sine of 30, and if you get a calculator you're unfamiliar with, or you're not sure what mode you're in, and when I say mode I'm talking about radians or degrees, quickly type those in and see that you get these expected values. If you don't, change the mode. So let's type this in, 35 times tan, where's tan? There's tan, of 72.5, and we hit equals, and we get, I get the wrong answer, but why is my answer wrong? Because I changed my mode to radians. Let's change it back to degrees, shall we? There we go. So right away, notice I get an answer that doesn't make sense because my calculator was in radians. That's better. So we get 111 meters. So therefore, the CN Tower in Edmonton is 35 meters. Oh, it's not 35 meters. It's 111 meters, pardon me. I hope this video helped.